Okay, in this video I'm starting integration of rational functions by partial fractions. So we have integral 5x minus 3 over x plus 1 and x minus 3 dx. So the title itself, method itself, giving us the idea, so we are breaking into partial fractions. What we're gonna do, we're gonna work out 5x minus 3 over x plus 1, x minus 3. And we are going to represent as a over x plus 1, breaking down, and plus b over x minus 3. Okay? So those are a over x plus 1 and b over x minus 3 are partial fractions. So what we're going to do next? We need to find a and b, the value of a and the value of b. To do that, we are going to bring to common denominator a over x plus 1 and b over x minus 3. So here we are getting, if we have x plus 1, so for fractions with a and b, partial fractions with a and b, common denominator is going to be x plus 1 and x minus 3, right? So which means here we are multiplying by x minus 3. Here also x minus 3. And here we multiply by x plus 1. And here also x plus 1. And what do we get? We are getting 5x minus 3 over x plus 1, x minus 3 is equal a times x minus 3 over x plus 1, x minus 3, and plus b times x plus 1 over x minus 3, x plus 1. Look what we have. We have the common denominator across the equation. So at this point, I can drop out a window this common denominator, and I will have 5x minus 3 is equal, well, a times x minus 3 plus b times x plus 1. Yes? So what do we get from here? 5x minus 3 is equal. So a times x minus 3 plus b times x plus 1, I want to bring in the format of a 5x minus 3, which means ax plus b. Okay, so let's open parentheses, distribute a and b. So we get ax minus 3a plus bx plus b. From here, 5x minus 3 is equal, like terms, ax and bx and 3a and b. So we take x out, we will get a plus b and plus 3a plus b. Okay? Oh, minus 3a minus 3a plus b. Okay, now if we compare, can we say, look here, 5x is this, and let me see, 3 is this one. Yes? Okay, so from here, what do we get? We are going to say that a plus b, 5 is equal a plus b, right? because we have both of them, both terms have x, 5x, and x times a plus b. That means 5 is equal a plus b, and negative 3 is equal negative 3a plus b, correct? Now let's solve system of equation and find a and b. So we get a plus b is equal 5, and negative 3a plus b is equal negative 3. Okay, so how we gonna solve it? Very easy. Here it's gonna be negative 1. We need to multiply negative 1, right, to get negative b. So if we distribute negative 1, gonna get negative a, negative b equal negative 5, right? Negative 3a plus b is equal negative 3. So when we add, what's going to happen? This is gone. We are getting negative 4a is equal negative 8. A is equal 2. If a is equal 2, so I'm plugging in this a is equal 2 in this equation, and I'm getting 2 plus b is equal 5, and from here b is equal 3. Okay, so once we have it, I can do the this integral, which is going to be 5x minus 3 over x plus 1 and x minus 3 dx. It's going to be a is 2 over x plus 1, right, dx, and plus integral 3 over x minus 3 dx. So from here, what do we get? I'm taking 2 out, and I get 1 over x plus 1 dx plus 3 integral 1 over x minus 3 dx. And from here, we are getting 2 natural logarithm x plus 1 plus 3 natural logarithm x minus 3 and plus constant c. Now let's solve system of equation and find a and b. So we get a plus b is equal 5, and negative 3a plus b is equal negative 3. Okay, so how are we going to solve it? Very easy. Here it's going to be negative 1. We need to multiply negative 1, right, to get negative b. So if we distribute negative 1, going to get negative a, negative b equal negative 5, right? Negative 3a plus b is equal negative 3. So when we add, what's going to happen? This is gone. We are getting negative 4a is equal negative 8. A is equal 2. If a is equal 2, so I'm plugging in this a is equal 2 in this equation, and I'm getting 2 plus b is equal 5, and from here b is equal 3. Okay, so once we have it, I can do the this integral, which is going to be 5x minus 3 over x plus 1 and x minus 3 dx. It's going to be a is 2 over x plus 1, right, dx, and plus integral 3 over x minus 3 dx. So from here, what do we get? I'm taking 2 out, and I get 1 over x plus 1 dx plus 3 integral 1 over x minus 3 dx. And from here, we are getting 2 natural logarithm x plus 1 plus 3 natural logarithm x minus 3 and plus constant c. Question number 3. We have integral x squared dx, and we have x minus 1, x squared plus 2x plus 1. Okay, let's decompose. So what we get? X squared over x minus 1. X squared plus 2x plus 1, it's going to be x plus 1 squared, right? It's a perfect squared. Okay, that is interesting. So we have x plus 1 squared here. How are we going to deal with the square? So we're going to have a over x minus 1 and then plus, since x plus 1 squared includes x plus 1 to power 1 and x plus 1 to power 2, then I'm going break it down and use both of them. So for b, I'm going to use x plus 1 degree 1, right, which will be x plus 1. And for c, I'm going to use x plus 1 squared. So which means if you have x plus 1 cubed, then you're going to go x plus 1, x to degree 1, x plus 1 to degree 2, and x plus 1 to degree 3, right? Because you have to include all degrees that involve that final degree, total degree you have. Okay, so from here, what we are going to get if I bring to common denominator, so x squared, it's gonna have a times, so I'm multiplying by x plus 1, right? X plus 1 squared, actually, since I have already here squared. So it's gonna be a times x plus 1 squared, okay? And then plus b. B is gonna be x minus 1, right? And x plus 1, because we have already, b has x plus 1. Therefore, from x plus 1 squared, I will have only x, okay, well, it's not working. I keep reading, and I think I'm confusing you. Okay. So we have x squared, x minus 1, and x plus 1 squared. This is equal. Bringing to common denominator, a common denominator is going to be what? X minus 1 and x plus 1 squared. Since here we have x minus 1, I need to multiply by x plus 1 squared, right? Common denominator is going to be x minus 1 and x plus 1 squared. Next, plus b over x plus 1. So out of x plus 1 squared, I will need only x plus 1, only degree 1, because 1 degree is there. I already have it. And times x minus 1, right? So it's going to be x plus 1 times x minus 1. And lastly, plus c. I already have x plus 1. All I am missing is, okay, let me write down x plus 1 squared. All I'm missing is x minus 1. Okay? All right. So everywhere we have the same denominator. We are dropping out a window. And we are going to get nice and clean x squared. That is equal a times x plus 1 squared plus b times, I don't know if I should put x squared minus 1. Let me put x squared minus 1, because x plus 1 and x minus 1 is x squared minus 1. If we need it, we'll open up again. And plus c times x minus 1. Okay, well, let's open up and figure out how much is a, how much is b, how much is c. So we get x squared is equal x plus 1 squared. Oh God, I have to open perfect square and then multiply by a. So I'm going to do all at once. So x squared, it's going to be ax squared, and then plus 2x, it's going to be 2ax, and plus 1 squared is 1, and plus a. Next, here, plus bx squared and minus b, and plus cx minus c. Like terms, ax squared, bx squared, right? And that's all I have. So for x squared coefficient, it's going to be 1. So I'm writing down a plus b is equal 1, right? Now for 2ax and cx, yes, it's going to be 0 equals 0, because I don't have there x squared plus, let me write down this way so it will be clear for you, x squared, so I put coefficient 1, and then plus 0x, and then plus 0, right? So which means 2a plus c, it's going to be equal 0, yes? In two available terms, a and c, negative c, is going to be a minus c is equal 0. Minus b also here. Okay, so minus b is equal 0. Okay? Well, let's solve it. How much we are going to get from here? A plus b equal 1. So what can I do from here? A from here, from the first one, let me write down first, second, third. I guess I can do that. Yeah, I see I can do that. I'm going to use first one and third one. So first one, I will have a plus b equal 1. And for the third one, I will have a minus b minus c is equal 0. So when I add them up, this is going to go gone. And I will get to a minus c is equal 1. Well, I have 2a plus c equals 0. Let's combine. 2a plus c equals 0. This is number 2. And this one, 2a minus c equal 1. So if I add them up, I'm getting, this is gone. I'm getting 4a is equal 1. And a is equal 1/4. Okay, so from here, what we're gonna do, we got A. Oh, A, let me see, I can find B. B is gonna be equal, A plus B is equal 1. So 1/4 plus B is equal 1. And B is equal 1 minus 1/4. 1 minus 1/4, we are getting 3/4, right? How I'm doing so quickly? 1 represent as a 4/4, and why 4/4? Because denominator is 4, and then 4 minus 1 is 3. Okay, and we need to find C. C I will find from the second one, to A plus C equals 0. So 2 times 1/4 plus C equals 0. So this is 1, this is 2, and C is equal negative 1/2. Okay, once we have it, so we are going to write down the following. So A is going to be 1/4. Well, might as well, let me put out, it's a constant. 1/4, 1 over x minus 1 dx, right? My A was, yeah, x minus 1, and then comes x plus 1, and then comes x plus 1 squared. Okay. Plus, B is 3/4, come out. And then we get the integral 1 over x plus 1 dx. And then minus 1 over 2 integral 1 over x plus 1 squared dx. Okay, so we are getting 1/4 natural log x minus 1, yes, plus 3/4 natural log x plus 1, and let's see what we can figure this out. If I use substitution and all stuff, I will get 1 over twice x plus 1. If we go through substitution, and plus our C. Okay. Thank you for watching, and I'll see you. I will continue this topic in my next video.